I suppose you're using automation when you're developing this software optimization. Have you already incorporated like machine learning algorithms into the software that you built, or were your company sort of too soon for that?
The company was a little bit too soon, but not a lot too soon. Then again, it's also machine learning and AI is a really interesting field that's developing very rapidly. So when we started out, we were mostly concerned with gathering performance data. Like the entire idea of Optimize at the time was we want to be the one place that gathers performance data from a whole bunch of different companies and then does aggregation and data analysis on top of these things to then make recommendations across the board to everybody to run things faster. Because one of the things that we had observed is that very quickly, the most important libraries in a software stack across multiple companies or even within one big company will, in their computational cost, eclipse the most expensive servers. So it turns out that the shared libraries are where all the CPU cycles are going. And the idea of Optimize at the time was if we sit on the treasure trove of data where everybody in the world is spending their CPU cycles, you can do really fascinating things with that data in terms of doing, for example, performance bug bounties, annotating a piece of GitHub and telling people, listen, if you can make this loop 10% faster, we've got $10,000 for you because you're going to save all the customers much more. So the plan was essentially build tooling to gather this performance data and make it really comfortable and easy and convenient for companies to gather that data, and then do analysis on the data, including machine learning and so forth, and then profit. And then due to an unfortunate or fortunate set of events, depending on how you look at it, we ended up getting acquired after we had completed the data collection part, but before we had gotten to the machine learning part. So we didn't do much AI there. That said, we did have some fairly successful experiments after the recent LLM wave arrived at having LLMs explain stack traces to developers, in the sense that a lot of performance measurements will give you, at some point, perhaps a stack trace into the Linux kernel. And then not everybody is very deeply into reading the Linux kernel. And it turns out that in order to get a vague idea of what a stack trace does, an LLM, even if it's not exact in what it's stating, is usually pretty useful to the problem of, can you roughly tell me what this is all about? Plays to the strength of the LLM, which is a vast memory and not necessarily precision in the details of what it's replying.
If you were to look forward, how do you think they're going to be used? I suppose in every sense, right? In the offensive, defensive, as well as software optimization space.
I gave a keynote in 2018 in Moscow, of all places, about the use of AI in computer security. And the thesis I had back then that was reasonably unpopular was that AI and ML works great if you're applying it to distributions that stay stable in time. So let's say facial recognition. Human faces do not evolve at a very rapid rate. Or text comprehension. The way we use language doesn't evolve at a very rapid rate. And it usually works less well if you have a distribution that changes often, or a distribution that changes maliciously. In 2018, a lot of the AI use cases in cybersecurity were aimed at detecting bad or detecting evil. And my thesis at the time was that this is actually using it to select it incorrectly because you're trying to target a fast-moving distribution or a maliciously changing distribution. And then there's other things that are perhaps more useful. And one of the useful things I was jokingly mentioning at the talk was, at the time, generative adversarial networks had just managed to generate credible human faces. And I had proposed that as a defender, I might be better used to create fake LinkedIn profiles so you find phishing campaigns early than detecting somebody that's actively trying to evade you. Because the distribution of human faces and LinkedIn profiles is much more stable than other things. I had joked that using AI to generate fake but plausible looking source code, so attackers that try to steal your source code, steal fake source code, may be a better use of AI on the defensive side. And I feel kind of vindicated by the development since, right? Because we've gotten much better at generating fake LinkedIn profiles or fake but realistic looking source code. And nowadays it may even compile, like LLMs have gotten so good that you may even get source code that you can build. So yeah, so on the defensive side, I think LLMs will have a huge impact on just generating garbage data. And that sounds like a useless thing, but generating garbage data is actually quite useful because the attacker usually cannot easily tell good data from bad data.